In this video, we will talk about how to count the number of elements in a non-disjoint union. And I want to motivate this with an example, which begins by saying that a website requires passwords whose characters can be letters, so the letters A, B, C up until Z, and they're not case sensitive, which means we don't care whether they're capital letters or lowercase letters, they're the same for our purposes. Or the characters can be digits between 0 to 9, those integers. And part A asks how many 8-character passwords begin with the letters LUV in that order. So for this part, I want to give you all the opportunity to try it. So pause the video for about 2 minutes to try this question. 4, 3, 2, 1, pause the video. Pause it for 2 minutes to try part A here. All right, so hopefully you paused it and tried this question for 2 minutes. Let's talk about it together now. So the first thing that I want to mention is this question had no mention of repetition and whether we are allowed to repeat letters or not. So because it did not mention it at all, that means that characters can be repeated. If the question had meant to say that characters should not be repeated, it would have explicitly said so. But since it didn't, it means that characters can be repeated. So let's think about this sort of space by space. So I have this password. It needs to consist of 8 characters. So I'll put a slot for each character, 3, 4, 5, 6, 7, 8. And we know what letters are going to go in the first 3 slots. We know it needs to be L, U, and V in that order. So for each of those first 3 letters, there is one way to choose what goes in there. Like this one has to be an L. One way to choose this letter. Similarly, for the U, there's one way to choose what goes there. It has to be a U. And for the V, one way to choose that. It has to be a V. Because the question says that the first 3 letters need to be LUV in that order. But it doesn't tell us anything about the letters in the remaining spots, which means we could pick from any of the characters that we have. So there are 36 total choices for each character, because there's 26 letters and there's 10 digits to choose from. So overall, that's 36 characters to choose from. So it's 36 choices for this one and 36 choices for that one, and so on for all of these. So I keep writing 36 there, and we're going to multiply all these numbers. So let's put in some multiplication symbols. And when we multiply them, we get 36 to the 5. And that's our answer for part A. All right, so let's do another part of this question. So let's move on to part B, which asks how many 8-character passwords begin with the letters LUV or end with LUV in that order. And in parentheses, it says inclusive or. So this or that it's saying that's written in the problem is an inclusive or. So we want to count the number of passwords that begin with the letters LUV, end with the letters LUV, and possibly both. Begin with LUV and end with LUV. That's what we mean by inclusive or. It could be both. So I first, for this question, want to talk about an incorrect solution, a really common mistake that people might make when first attempting a question like this. So what I'm going to do is I'm going to define some sets for the 2 types of things we're considering, either beginning with LUV or ending in LUV. So let's let B be the set. So I'm going to put some curly brackets to denote it's a set, the set of passwords beginning with those letters LUV. And I'm going to let E be the set of passwords ending with LUV, and close that bracket. So our goal in this question is to count the number of passwords that either begin with LUV, so the number of things in B, or the number of passwords that end with the letters LUV, so the number of things in E, as well as possibly both, passwords that begin with LUV and end in LUV. So overall, our goal, thinking about this in terms of sets, is to count the number of elements that are in the union of B and E. One of the ways that I can tell it's a union is because this problem has an inclusive OR here, and that's what a union symbol means. This means it means the word OR, and it's inclusive. Okay, so I'm going to first do this incorrectly. So my strategy is going to be I'm going to try to count the number of things in this union. Let's count the number of things in B. So the number of elements in B is the number of passwords that begin with the letters LUV. But we already figured that out in part A of this question. So as in part A, we know what this is. It's 36 to the 5. Okay, and now let's count the number of passwords that end with the letters LUV. So we can do that in a pretty similar fashion to how we did part A. Let's think about it in terms of each of the characters. 1, 2, 3, 4, 5, 6, 7, 8. We know the last 3 spots got to be occupied by LUV. So for each of those, we have one choice for what we put there. One choice for that character, one choice for that one choice for that one. The last one, for example, has to be a V. And for the first 5 characters, we have 36 choices for each character. So we are going to write 36 choices here and 36 here. And we're going to multiply these times 36, times 36, times 36. And I'll keep multiplying with the 1, and then times that one, times that one. And this also gives us 36 to the 5. So that's how many passwords end with the letters LUV. So now I'm going to give a wrong answer. And then after I write it down, we'll talk about why is it wrong. So the wrong answer is to say that if I'm trying to count the number of elements in B union E, to say that that's simply the number of elements in B plus the number of elements in E, so simply just adding up the number of passwords that begin with LUV and the number of passwords that end with LUV. So beginning with LUV was 36 to the 5, and ending with LUV was also 36 to the 5. And if you add these together, these two numbers are the same. It's kind of like adding x plus x, which is 2x. I'm going to use the same idea for 36 to the 5 plus 36 to the 5. It's 2 of those things, 2 of 36 to the 5. So I'd write it like that. So this, unfortunately, is not right. So why is that? Well, the reason is, if I think about n of number of elements in B, the number of passwords that start with the letters LUV, this, I should say no equal sign, this includes passwords, that end in LUV as well. So if I'm looking at passwords that begin in LUV, well, some of those also end in LUV. Okay, so n of B counts those as well. And if I think about what I've done when I counted n of E, the number of passwords that end in LUV, well, that includes some passwords that begin in LUV. And what that means is we count passwords that start and end in the letters LUV twice. And that makes us sad. It means there's some passwords we've double counted. So before I get to the correct solution, I want to give a sort of a visual explanation for this. So a visual explanation. Because what's going on here is, imagine that I have a Venn diagram, and this is the circle B, the passwords that begin with LUV, and this is the circle for the set E, the passwords that end in the letters LUV. So these circles overlap because there's some passwords that start with LUV and also end in LUV, and that's this intersection. Okay, and this is all going to be in some universal set of all passwords of this length. And here B, as I see in this picture, B and E, they overlap, which means those sets are not disjoint. And when they're not disjoint, this formula that we wrote down for the number of elements in the union is not true. This is only true if our two sets are disjoint. Okay, so how do I do this correctly? Well, we've seen this before when looking at the union of not disjoint sets, but let's just restate it. Oh, whoops, not highlight. So the number of elements in the union of B and E is actually equal to the number of elements in B plus the number of elements in E, but I got to subtract the number of elements in the intersection because I counted them twice. So to not count them twice, I need to subtract the number of elements in that intersection. So we know n of B. We wrote it above. It was 36 to the 5. We know the number of elements in E that end in LUV. That was also 36 to the 5. So I just need to count the number of elements in the intersection of B and E. So how do we get that? B intersect E is the passwords that begin with, I should say, that begin and end in the letters LUV. In fact, maybe I can put curly brackets around this to say, oh, it's the set of all passwords that begin and end in those letters. So if I'm trying to count the number of elements in that intersection, so the number of passwords that begin and end in those letters. Let's make our slots again. 1, 2, 3, 4, 5, 6, 7, 8. So I know I got to begin with LUV. Let's end with LUV. So for each of those letters, there's just one choice. This one has to be an L. This one has to be a U, one choice. This one has to be a V, one choice. Similarly at the end, one choice for each of these. Let's put some multiplication symbols. Multiplication, multiplication. And for those middle two spots, they could be any of the 36 characters. So I would write 36 and another 36. And multiplying these, we get 36 squared such passwords. I'm just going to write words. So at this point, we are ready to write down our final answer. Our answer is, we do the number of passwords that begin with LUV, 36 to the 5, plus the number of passwords that end with LUV, which was 36 to the 5, minus the number of elements in the intersection, which was the number of passwords that begin and end in the letters LUV, which was 36 squared. And we could simplify the first two terms by adding them together. We saw above that was 2 times 36 to the 5. And then we get minus 36 squared. That's as far as I could simplify this without a calculator. And I'm going to leave it like this. Passwords. But of course, if the question asked us to simplify it fully, we could use a calculator to work out what this is. And that's my answer. Alrighty, so in terms of our goals for the section, we finished our last goal, which is to count the number of elements in a union when the sets in our union are not disjoint.